Afternoon once again. Today we are going to continue with confidence intervals. We will look at confidence interval of the mean of a population, and then we'll look at an example of proportion, where we, instead of estimating the population mean, this time we estimate the population proportion by means of a confidence interval. So just on the assignment, I think a lot of people sent me their assignments, which is good. I haven't gotten through them. When I do start sorting them out, then I will confirm that I have received them. So if you have sent it, you can see it in your sent box, then it's fine. Don't worry about it. Okay. For those who submitted the assignment late, there will be a penalty. Yeah, that's pretty much it. The test will be on Friday. It'll be, for you guys, part-time students, it'll be in the evening. Mr. Mwahi said from 6 o'clock to 11 o'clock. I'm assuming that doesn't mean you're writing for 5 hours, so you just find time within those 5 hours in order to write. Okay, so somebody mentioned that they have another test sometime on Friday, so you have 5 hours to do the test, so you should manage your time so that you're able to do both if they do happen to clash. Okay, but as Friday draws near, if there's anything else to clarify, then we will get to that. I think for now that is fine. Please keep studying. The questions that you will get are similar to the ones that I've been doing in the exercises. Like I said, all the questions that, or most of the questions that I do in the exercises, these are questions that I got from past papers, past tests. So when people are asking me for past papers, these exercises are exactly what you're asking me for. Okay, so Friday evening, you'll have about 5 hours. Make sure you're able to do the test within that time. So before we continue with this question, which was question 1 in exercise 5, do you have any questions, anything that I need to clear up before we, or are we fine?
So far, so good.
Okay, right. So let us look at the exercise. So this was the exercise that I gave you guys to do. I hope you managed to finish it. We did the first few questions. We constructed a 90% confidence interval and then also constructed a 95% confidence interval. The last question said compare the width of the intervals at 90% and 95% and give a statistical conclusion based on your findings. Can somebody answer this question? How did you answer C? Or what was your answer for C?
May I attempt?
Yes.
Okay, so the observation here, in my opinion, is that the larger the, the smaller the interval, then, how do I say this? The smaller the, it's sort of like in ratio with the confidence percentage, in the sense of like, if the interval is quite small, then the percentage of the confidence will be smaller, if I can say in that sense, because the accuracy is very limited. Whereas if the interval was larger, then the confidence percentage will be larger as well, because there's that larger space within the accuracy, if I can put it in that sense.
Okay, that is exactly right. So here we just say the higher the confidence level or our degree of confidence, the wider the interval. And that makes sense. If you give a wide range, then it's more likely that your answer will lie in that range than if you limit it to a small group or sorry, a small interval, that your answer will lie in that small interval. Okay, so the higher the confidence interval, just write that. This is C. The higher, oopsie, sorry, the higher the confidence level or wider the interval and vice versa. Okay, so you can say this in your own words like John did. That's fine, but the main thing I want to see is the higher the confidence, then the wider the interval. Or you could say the lower the confidence, the narrower the interval. That's also correct. Okay, so either of those is fine. Then move on to the next question. Number 2, suppose we have drawn a sample of 36 from BBS 1AB students and calculated the mean of their results as 55. So we have this 55 over here. Now this 55 is not the population mean. It is from our sample of 36 students and a standard deviation of 6. Now this standard deviation is the standard deviation of the sample. So in this case, we don't know what the standard deviation of the population is. So remember the steps I told you to follow if you are trying to decide, should I use a T or a Z distribution? Okay, then after that, we have to construct a 95% confidence interval to estimate the true unknown population mean for BBS 1B results. Okay, so let us do that. This is number 2. Okay, we are told that our sample is made up of 36 students, so n is equal to 36. We're told that the average of the sample is 55. And we are also told that the standard deviation of the sample, so S is equal to 6. So this is S and not sigma because this belongs to the sample. So if it was the standard deviation of the population, then I would use sigma. And here, sigma, okay, my pen is not working now. So sigma is unknown. Okay, so remember the steps to follow. The first question is sigma known? Yes or no? Here in this case, sigma is not known. Then the second question was, is the sample size greater than or equal to 30? Here our sample size is 36, which is greater than or equal to 30. So we are going to use a Z distribution. Okay, so now that we know what we are going to do, the only thing left is to construct the interval. So we know how to do this. This is X bar. Say X bar minus Z of alpha over 2. Then we multiply this by the standard error of the mean, which is S because we don't know what sigma is, divided by the square root of n. And this is less than or equal to the true population mean, which is less than or equal to x bar plus z of alpha over 2 multiplied by s over the square root of n. Okay, now this alpha over 2, remember we want a 95% confidence interval. So if we want a 95% confidence interval, the alpha that we are talking about is what do I need in order to make this 95% equal to 100. So I need 5%. So you say that our alpha here, I'm writing this in red because this is not necessarily part of the calculations, but just something that you need to know. So we say that alpha is equal to 5% because that is what is missing from this 95%. And we know that 5% is just equal to 0.05. So alpha over 2 is equal to 0.05 divided by 2, which is 0.025. Now, normally what we would do if we didn't know what the value is that we would go to our standard normal table and then we would look for this value. We would look for this value and then see what z-score corresponds with it. But with the confidence intervals that we will be constructing, usually it will be 95%, 99%, 90%. And for those ones, we have already established what those are. Let me see. They're over here. So these are the ones that we will normally work with. And 95%, this is plus or minus 1.96. So z of alpha over 2, I'm just going to take this 1.96 and substitute it for z alpha over 2. Okay, so our z alpha over 2, this is equal to 1.96. Okay, so we will substitute that over here and over there. We know what S is. It is 6. We know what N is. We know what X bar is. All we need to do is construct the confidence interval. So doing that, we have this X bar. This is 55 minus 1.96. Then you multiply this by the standard deviation of the sample, which is 6, divided by the square root of n, which is square root of 36. This should be less than or equal to our true population mean, which is less than or equal to 55 plus 1.96 multiplied by 6 over the square root of 36. So on the left-hand side, can somebody work this out and tell me what you get?
$53.04.
Okay, so this is 53.04. Okay, now somebody else tell me what do you get on the right?
Is anyone else going to answer?
I hope so. Guys, this class is supposed to be interactive. So I want to see if you guys are following. So please, when I ask you to work out something like this, please do it. I want to confirm if you're following or not. Is anybody going to give the answer?
Let me know if I should assist.
Go ahead.
I got 56.96.
Okay, so this is 56.96. Okay, so this is our 95% confidence interval. And again, because this is a word problem, we should always write a sentence to answer our question. So we can say that we are 90% confident. Sorry, not 90, 95% confident that the true mean the BBS 1B results lies in the interval okay, maybe from 53.04 to 56.95. So again, you can word this a little bit differently, but I must see that you are 95% confident, and then you state the interval in which it lies. Okay, let's look at the next question. Okay, that was number 3. We're told that an F&B branch located along Independence Avenue has an improved access for serving customers during the noon to 1 p.m. peak lunch hour period. The waiting time of all customers during this 1 hour is recorded over a period of 1 week. A random sample of 15 customers is selected, and the results are as follows. First thing, find the point estimate for the mean waiting time for the improved process. B, give a 95% confidence interval for the true unknown average waiting time for the improved process. Interpret your confidence interval. Okay, so here you can see that we do not have a point estimate given. Because we are looking at the average waiting time, our point estimate in this case should be our sample average. So we have 15 points. We know how to work out the average. You add everything together and then divide by 15. Okay, so that is what I would like you guys to do. Can you work out this average, the average of these numbers over here? So take your calculator, you add each of them, and then you divide by 15. Okay, do we have anybody who's done the working? Can somebody tell us what is the mean of this data over here?
I got 4.24, ma'am.
4.24. Can you give me more decimals?
Okay, it's 4.24466.
24466. Let me see. Okay, I got 4.24666, not 244.
Yeah, it's actually
I also got
24667.
4.246 recurring.
Okay, so here we say that our point estimate is this is x bar, which is the sample mean, and the way we work this out is we add all the values together and then we divide by n. So if you did this, this value I got 63.7, and then we divide this by 15, which gives us 4.24666, and then it continues like that. And we can leave this to 4 decimal places, 0.2467, like that. Okay, so our point estimate is x bar, and x bar is equal to 4.2467. And the next question says, give a 95% confidence interval. Now, when we're estimating the confidence interval, we need to know what distribution we are dealing with. Now, in this scenario, which one are we going to use, Z or T? Any ideas? Can you follow the chart that I gave you? So look at the information that we are given over here, and where do you end up? Should we use a Z or a T?
Sorry, ma'am. Good evening.
Yes. Hello.
Sorry, I just joined the meeting late due to network issues. I wanted to ask, is this the homework question that we're doing as of now? I just joined.
Yes, it's exercise 5. We were continuing
Oh,
from where we left off last week.
okay. Thank you,
Yeah.
ma'am.
All right. So any ideas? What should we use, Z or T here? Do you guys not remember the flow chart I gave you to use? This one over here. So look at the information that is given in the question, and then somebody tell me, are we going to use Z or T?
I think it's the Z name.
Okay, how did you get to the Z? Or why did you say Z?
Because we got our mean now, and so it's, do I know the Z? So it's yes. I don't
Do you know what? Sorry, I didn't get that. So you
know,
start
ma'am.
over.
It's fine.
Okay, so you have to start over here. It says, do I know sigma? So what is your answer to that? Yes or no? Do you know what sigma is?
Mm-hmm.
Let's look at the question. Now remember, sigma is the standard deviation of the population. Now, when we read this question, are we told what the standard deviation of the population is?
No, ma'am.
No, we are not. So our answer to that would be no. So we are here. This is where we start. Do we know sigma? No. So we go down this way. Then the next question we have to ask, is n greater than or equal to 30? So is our sample size greater than or equal to 30? What is our sample size in the question? How many people did we sample? Or how many customers did we sample?
15.
15. So is 15 less than or equal to 30, or is it greater than or equal to 30?
Less, ma'am.
It's less than. So here we say, is the sample greater than or equal to 30? Our answer is no. So we end up at the t distribution. So the right answer to that would be, we have to use a t distribution. Okay, let me go. So here, this is 3.2. Okay, 3.2. We will use t distribution. So instead of z. Okay, now before we work out how to use the t distribution, there are a few things that we need. So remember how we work this out. It is always, the confidence interval is always given like this, x bar minus, in this case, we will have t alpha over 2. And then here I will have df. df represents our degrees of freedom. So that's just a statistical term. Don't worry about it. We'll go over it just now. And then we'll multiply this by our standard deviation of the sample, or the standard deviation of the sample. So S over the square root of n, and then our mu, then again x bar plus t alpha over 2 with some degrees of freedom multiplied by s over the square root of n. So you can see here the only difference between when we were using the z and now that we're using the t is this value over here. So I'm sure you can guess this is a value that we're going to get from the t table, just like we got the z value from the table. So we're going to get this one from the table. This is our standard deviation. This is our n, which we know is 15, and x bar we just calculated above. Now the standard deviation is not given from the question because we are just given the data. So the standard deviation is for us to work out. So before we get to this t value and how we read it from the table, I want us to work out the standard deviation. Now we know the variance, s squared, is given by the sum of all the squares minus the square of the sum, then we divide this by n, and then the whole thing is also divided by n minus 1. So this is the formula. Now to get this one over here, what you will do with all those individual 15 entries is you will square them and then add them all together. So you'll give me a value over here. Now this over here just means add all the terms together and then square it. But we already worked this out. We got 63.7. So we'll just square 63.7. N is 15 and then divide by n minus 1. So can we work this out? So remember, this means you square each of the 15 values, then add them together. So what you will do is this 4.2, you square it, then you add it to 5.5 squared, then you add it to 3.02 squared, then you add it to this one squared, all the way up until the end. So can we do that and see what we get?
Must we tell you our working, or should we just give you the final answer?
Or you can give me the final answer if you have it.
Okay, should I wait? Or can I give it?
1 more minute.
Okay.
Okay, what is your answer for this part here?
I've got 21.90202296.
That is not what I have. Are you sure you did it correctly? How did you get 21
Yeah.
here?
Well, okay, I already have the sum of the what you call it, the mean
Yeah,
squared. Wait, I got it wrong. I took the mean instead of the. Okay, never mind. I see where my mistake is.
Okay. Anybody else who has this already? So remember what I said about this one. This means square each of the individual 15 entries and then add them all together. Anybody have an answer?
I've got it now.
Okay, what do you have?
I've got 2.6655666667.
Again, I don't think that's right because look
But
at these numbers. When I square them, like this one, for example, when I square it, I'll get maybe 16 or 17 point something. This one is like 25 point something. This is 9 point something, 10 even. So this should
yeah,
be a
if I
pretty
added, if I add all of that, I get 307.8306. Or did I
yes. That
calculate
is
that
what you
wrong?
should get.
Okay, so that's good.
That's what you should get. Okay. So when you square each of them individually and then add them, you should have 308.8306. Okay, so you square each of the terms individually and then add them together. Okay, and then for
Did you get
this one,
308?
yes, 30, sorry, it's 7. I have 7 here. Why did I say
Yeah,
308? I have
7.
307.83. Okay, that's right. Then
Yes.
this one here, the sum of all the x's, that means add everything together. But like I said, we worked that out when we were calculating the mean, which was 63.7. So this 63.7, I'm going to square it. Okay, so take note of the differences between this expression here and this one over here. This means square first and then add. This one means add all of them together and then square. So this I will then divide by 15, and then everything again is going to be divided by 15 minus 1, which is 14. So if you want to type this in on your calculator, you can put the brackets like that. And can somebody tell me what you get from that? So the brackets, you don't need to write them like in a test. This is just to show you how you should type it on your calculator.
Ma'am, the answer that I gave you was the initial answer I was referring to.
Oh, okay. I see.
Yeah, I thought we were not going to do step by step, but okay, got
Oh,
it.
okay. For the test, I want to see all these steps, not just the final one.
Yes, ma'am, I did do it like that.
Okay. Okay, can somebody else tell me what do I have over here? So this is a simple calculation. Shouldn't be too difficult. Do we have an answer from somebody? Please don't be shy. That's how we learn. Okay, I got 2.6655666, and then it continues in that manner. Now remember, here we are not looking for s squared. This is the variance. So when you have s squared, that is the variance. We're not looking for the variance. What we're looking for is the standard deviation. So the standard deviation is just the square root of this. So that is easy enough to do. S is equal to 1.6327. If I write this to 4 decimal places. Okay, so now that I have my standard deviation, remember why I was working it out in the first place is so that I could come and use it over here. So this interval, I needed to know what x bar is, which is what I calculated in the first part of the question. I needed to know the standard deviation, which I just got now. I know what n is. I can always work out its square root. Now comes this part over here. Okay, now this T alpha over 2 and the degrees of freedom, this we are going to get from the T table. So I will show you what the T table looks like. So this is our T distribution. So it looks similar to the normal distribution in its shape, that is, except over here, instead of having t-scores, we have our degrees of freedom, and then over here we have our alpha. Okay, so we have the alpha over 2 that we're going to use. That is what we have over here. Okay, so instead of looking for it in the table like we did with the normal, we would find it over here and then try and get the z-score over here. Here with the T table, our alpha over 2 is in the first row, and then the degrees of freedom are in the first column. Now the degrees of freedom are always one less than the number of terms that you have in your sample. So here we have 15 elements in our sample, or 15 customers, so our degrees of freedom are going to be 14. So it's 14 degrees of freedom. And then what is our alpha over 2? It is 0.05 divided by 2, which is 0.025. So what I do is I look for the area where 0.025 meets with 14. So if I go like that, I will end up with this value over here, 2.14479. Okay, so in this column, this is my alpha over 2, and this values over here, these give me my degrees of freedom. So I'm going to take this value and then substitute it in the same way I did when I got my Z alpha over 2. So let us do that. So we know what x bar is. We just got this from our table. So remember again, degrees of freedom is just one less than the number of elements that you have in the sample. So if you have 15 elements in your sample, your degrees of freedom are 4. If you have 10 elements in your sample, your degrees of freedom is 9, and so on. And you can see our T table goes to 30 over here. So that's why when we have more than 30, we no longer use the T table, we go to the Z table. Okay, so now let's substitute everything we know here and find our confidence interval. So we say that our mean, which we worked out, this is 4.2467 minus our T value is 2.1449, and then we multiply this by the standard error. which is the standard deviation 1.6327 divided by the square root of 15. Okay, 15. Yeah, 15. And this is less than or equal to mu, and this is less than or equal to the other part, which doesn't fit over there, but you can add this part over here. So this is a simple calculation, again, that is not very difficult to do. Now you can see here, it is very important that at each step your answers are correct, because if you get a wrong value over here, it's going to affect the answer you get over here. And so on. So make sure you're doing everything as accurately as possible. So when I work this out, what I got is 3.3425. This is less than or equal to, let me copy everything and paste it on the other side. Okay, just want later on when you are reading this to revise, you can see everything nicely. Okay, and I said from there I got 3.3425. This is less than or equal to mu, which is less than or equal to 5.1509. Okay, and then from there we conclude that the true unknown average waiting time with 95% level of confidence. Okay, so that is our conclusion. Okay, so again, just be careful with all the calculations that you will be doing. Make sure that at each step you do them correctly, because the errors that you make in the previous step are carried forward to the next one. Okay, then
Ma'am, I have a question here.
let's go ahead.
Because the numbers or the data that we were provided were in 2 decimal places, is it safe to have our answers also at 2 decimal places?
I think that will depend on what is stated on the question paper. Let me see this one over here. Okay, I would prefer 4 because there is nothing given, but that's not such a big problem. Usually we want 4 decimal places. Okay, I see here there's nothing stating how many decimal places you should leave it in. I think 3 is standard, 4 just to be more accurate, I guess. I would prefer 4.
All right, ma'am. Thank you.
Okay. Then the next question. Okay. So the next question, what should be the value of Z used in a 92% confidence interval? So this one just involves us reading from the Z table. So remember, 92%, you first need to work out your alpha. And we say that alpha is whatever you need in order to make this equal to 100. So you need 8%. 8%, this is 0.08. And then you divide this by 2. So you are looking for 0.04 on your Z table. So let us go to our Z table. So we want 0.04. Okay, this is it. Yes. Okay, 0.04. So remember, with the Z table, we look for the probability here and then see what Z value corresponds to that. Okay, so 0.04. Okay, so the closest values I see are, okay, this is the closest one really. Okay, 0.0401. This is a little bit far. This one also is quite far, so I would take this one. And this corresponds to negative 1.701235. Okay, so this is the value that we would take. Okay, so let me write that down. Okay. Okay, so this was number 4. Okay, for number 4, we want 92% confidence interval. So this means that our alpha is equal to 8% because that is what I need in order to make this equal to 100. Then from there, I will say alpha divided by 2, which is just 4%. And this 4%, I convert it to 0.04, or I rewrite it as a decimal. Then this 0.04, I go and read from my table. So there I was looking at the negative values, or I could also look for, let's see. Okay, no, that's fine. Okay, so we read the value from our table, 0.04. I got 1.74. Here it's negative, but the areas, our Z distribution is symmetric. So the value I would pick is 1.74 from the answers that are provided here. So this is the answer that we have. Okay, so here the answer is B, 1.75. Okay, so this question is just checking, are you able to read the table? Given the probability, can you tell what Z score gives that probability? Okay, then number 5, is that one fine? Are we okay with reading?
No, I'm confused with regards to this, to number 4. And I was trying to follow the video, but the internet isn't so good, so it's kind of slow on my side.
Okay, what is the problem?
Okay, I can work out the z value with the alpha divided by 2. I can work that out. But then how are we substituting that answer with the numbers provided for A, B, C, and D?
No, we're not. This was a multiple choice question. I got this from from the exam. So this was a multiple choice question. So we're not substituting. Um,
Okay, I thought
the right question,
I
the right
I was
answer.
busy. Yeah, I thought we had to substitute the answer for those ones and give what you call this the answers for those particular ones. Okay,
No.
I understand now. I'm sorry.
Yeah. So I think you've seen with the exam paper that I have over here. Usually the first 10 questions or so, you have multiple choice. So that is one that I picked. I don't know, did I get it from this paper? Maybe not. Okay, so this was a multiple choice question, not that you need to do anything with the individual solutions. Okay, so it's just reading from the table and you see which one corresponds with the values that you are given. Okay, then number 5, we are told that biology student at a major university. Okay, the grammar here is not right. Okay, I'm guessing it's supposed to say a biology student at a major university is writing a report about bird watchers. She has developed a test that will score the abilities of a bird watcher to identify common birds. She collects data from a random sample of people that classify themselves as bird watchers, and the data is given below here. So we have to calculate the sample mean score and then estimate the mean score of the population of bird watchers with a 90% confidence interval. So this is similar to number 3 that we did. Instead of being given the mean and the standard deviation right away, we have to work those out. So we will have to work out the mean. We add everything together, divide by 1, 2, 3, 4, 5, 6, 7, divide by 14. That will give us the mean, and then we construct our confidence interval. Now here, because I do not know what a sigma is, it's not given to me in the question. So sigma is not known. So the first question I would ask myself, is sigma known? The answer is no. Then I ask myself, is the number in the sample, is the number of bird watchers in the sample less than 30? Yes, it is. So we are going to use a t distribution over here. So let us do this one. This is number 5. Okay, so you guys work with me. First thing we need to do is find the mean. So you add all those terms together. 9.1, 8.5, 5.9, 7, 5.2, 7.3, 7.6, 8.2, 6.4, 4.8, 5.8, 6.2, 6.2, and 8.5. Okay, so for A, we have to work out the mean, or x bar. So we know that x bar is equal to the sum of all the x values, then we divide by n. So I got 95. I hope that is what you also got. And then we have to divide this by 14. This gives 6.78 5714286. We can approximate this to 4 decimals, so 6.7857. Okay, so now that we have our X bar, okay, we need to build our confidence interval. Now for our confidence interval, we need to know what S is. And we get S by taking the square root of the variance. So the formula for the variance, again, this is equal to the sum of the squares minus the sum of all the individual elements squared divided by n, and then we divide by n minus 1. So this one can work out the same way we did with sigma of x, which means square each of them individually and then add them together. Okay, so I'll give you a minute to do that one. Let me show you the values in case you don't have them. So you square each of them, 4.5 squared plus 9.1 squared plus 8.5 squared plus 5.9 squared plus 7 squared plus 5.2 squared plus 7.2 squared plus 7.6 squared plus 8.2 squared plus 6.4 squared plus 4.8 squared plus 5.8 squared plus 6.2 squared plus 8.5 squared. And I got 672.78.
Same.
Okay. And then this one over here, this is just the 95 that we got over here. So I will say 95 squared, and then I will divide that by 14. Then this is all going to be divided by n minus 1, so 14 minus 1. So you can write the 14 minus 1 like this, or you can just write 13. Now remember, when you type it in on your calculator, put brackets over there. Okay, so again, work this out on your calculator. Okay, I got 2.164395604. Now remember, this is the variance that we were calculating. You still need to work out the standard deviation. Now to get the standard deviation, all you need to do is get the square root on both sides. So this value here, on your calculator, you can just type square root and it will work out the square root of that one. So try not to round this one off, otherwise it'll round off your, if you round off too early, your final answer will be quite far from where it should be. So when we do that, we get our standard deviation is 1.471188.501. Okay, now this standard deviation over here, I can round off to 4 decimal places. So it's 1.4712. So I have my standard deviation. I know what n is. I know that n is equal to 14. I know what x bar is. We worked it out over here. This was our x bar, 6.7857. Let me just copy it. Okay, so that is our X bar. Now the only thing we need now is our T alpha over 2 and the degrees of freedom. So here, what we're actually looking for, because we want a 90% confidence interval, this is what was stated in the question, 90% confidence interval. This means that our alpha is 0.1, and then we divide that by 2, so we have 0.05. So this is T of 0.05. And then our degrees of freedom, that just means one less than this value that we have over here. So that is 13. Okay, and this value, we said we read it from our table. So we'll go to the row where we have 0.05 and then the column where we have 13. So when we do that, okay, so 0.05, there it is. And then we scroll down where we have the degrees of freedom, which is 13. And we see where the row and the column meet. It's this value over here, 1.770933. Okay, so we have everything that we need in order to construct our confidence interval. So we will say, I'll just write down the formula, X bar minus T 0.05 over 13 multiplied by our standard deviation over the square root of n. This is less than or equal to mu, which is less than or equal to X bar plus T of 0.05 comma 13 multiplied by S over the square root of n. We have each of these individual values. Now we just substitute. So X bar, we say this is 6.7857 minus our T value of 1.70933, and then we multiply this by S, which is 1.4712 divided by the square root of 14. This is less than or equal to our population mean, which is less than or equal to, I'll write it in the next row. So this is, let me just copy everything. Let me shift it a little this way, except that over here I will have a plus and not a minus. So the left hand side and the right hand side are identical except for this plus and that minus over there. Then again, this you can easily work out on your calculators, so you can calculate with me and confirm that what I have is correct. Okay, on the left hand side, I have 6.089378461, and then on the right hand side I have 7.48202153 and then you can round it off to 4 decimal places. So this is 0894. New here, 7.4820. And then after that, you can write a statement, which I will leave to you guys to do. So remember the question, where was it? Okay, estimate the mean score of the population of bird watchers with a 90% confidence interval. So you can say something like we are 90% confident that the true mean score of the population of bird watchers is in the interval from 6.0894 to 7.4820. Okay, so that is how we would do that one. I want us to quickly do another question, but this one involves proportion instead of mean. The way we do them is pretty much the same. We're still constructing a confidence interval. So this is the question that we have. It says if 500 customers queued at a bank in 1 week during peak hours and 7 of these 75 of these customers were served within 4 minutes of being in a queue, estimate the proportion of customers who were served within 4 minutes and give a 95% confidence interval for this estimate. Interpret your confidence interval. Okay, so this one we would do it in pretty much the same way, except instead of using X bar, we will have P, and then our standard error is not going to be standard deviation over the square root of n. Our standard error is going to be the standard error of the proportion, which is P multiplied by 1 minus P, everything divided by n, and then that is all under one big square root. So let us do that one. Okay, so our confidence interval is going to be P minus, we will use the Z distribution. Then we multiply by the standard error, not the standard error of the mean, but the standard error of P, which is a big square root. Then P, 1 minus P. Now this 1 minus P, sometimes we represent it by Q. So when you see P and Q, Q is just 1 minus P. Then we divide this by N. Then we have our population proportion, which is pi, as you remember. This is less than or equal to P plus Z alpha over 2 square root P, say 1 minus P, divide by N. Okay, so you can see the idea is basically the same. This Z value, because it's a 95%, then we know how to get that from the table. And 95%, we say that is 1.96. Okay, and this is the standard error of the population. I hope you remember that. Of the proportion, sorry. I hope you remember that. Okay, so let us see what we are given in the question. Okay, so our P, this is equal to X over N. So we are told that 75 customers out of 500 were served within 4 minutes. and this is equal to 0.15. Okay, this is 0.15. Then z of alpha over 2, this, as we know, this is 1.96 because we are looking for a 95% confidence interval. So for 95, 90, 99%, those ones we don't need to read them from the table. They're the ones that we use the most, so you should know them already. But if you forget, you can always read them from the table. Okay, so we know what our Z alpha over 2 is. So our P is 0.15. Then our Q, which is just equal to 1 minus P. This is 1 minus 0.15, which is 0.85. Okay, so again, remember this is Q. So if sometimes you see PQ over N, they mean exactly the same thing. So we can now construct our confidence interval. So P, this is 0.15 minus our Z score, which is 1.96. Then we multiply by the standard error, which is this big square root, 0.15 multiplied by 0.85. So the square root should cover everything. And then we divide by n, which is 500. This is less than or equal to our population proportion is pi, not mu. And this is less than or equal to, so I'm going to copy and paste just to save time. Okay, then instead of a minus over here, I should have a plus. So you can quickly work this out on your calculator. Let me again copy everything and put it on the next page. Okay, so on your calculators, say 0.15 minus 1.96 multiplied by the square root of 0.15 times 0.87 divided by 500. Make sure that everything that you are multiplying over here is under the square root. So if you don't type it in correctly, it might just take the square root of only this 0.15, and then your final answer is not correct. So I got 0.1187013099. Hi. This is 0.1812986,901. Okay, then we can now round this off to 4 decimal places. This is 0.1187. 0.1813. Okay, then you can write a statement saying we conclude that the proportion of customers who were served within 4 minutes lies in the interval of 11.87% to 18.13% at 95% level of confidence. Okay, so that is how you would then answer it. So you can see the one that deals with proportion is pretty much the same thing. When we're constructing our confidence interval, we just need this expression over here. This is our Z value, which you know how to get. This is our standard error, which for proportion is the square root of PQ over N. And then here, instead of mu, I have pi. Okay, I see that we have gone beyond time, so I will stop the class now. But if you have any questions, you may ask me and we can clear them up.